Hi guys, this is Allison, Sam, and Steph back again for problem 4b. So 4b says, prove if Si and Ti are members of the closed interval xi minus 1 to xi, then the sum from I to n of the absolute value of f of Si minus f of Ti delta alpha I is less than epsilon. So we started by reminding you the definition of mi is it's the smallest possible value of f of x over that closed interval. And the definition of capital Mi is the largest possible value of f of x over our closed interval. So we are given that Si and Ti are members of our closed interval. So that means that f of Si has to be between the minimum value, Mi, and the maximum value, capital Mi. Same thing for f of Ti. It has to be greater than or equal to our minimum value, or less than or equal to our maximum value. So knowing that, we can say that f of Si minus f of Ti has to be less than or equal to the maximum minus the minimum, because the maximum minus the minimum is as big as our value can be, right? So by definition, U of PF alpha is the sum of capital Mi delta alpha, and L of PF alpha is the sum of little mi delta alpha. So if we want the sum of our f of Si minus f of Ti delta alpha, just like in our inequality up here, we know that it has to be less than or equal to the maximum, so U PF alpha, minus the minimum, L of PF alpha. So U of PF alpha minus L of PF alpha is as big as the value can get, so our value has to be less than or equal to it. So we are given, in problem 4, that U of PF alpha minus L of PF alpha is less than epsilon. So we can make a big chain of inequalities that says the sum of f of Si minus f of Ti delta alpha less than or equal to U of PF alpha minus L of PF alpha, which we are given is less than epsilon. Therefore, the sum of f of Si minus f of Ti delta alpha must be less than epsilon, and that's what we're trying to prove.